unpaused it. So now, and just to recap, so it'll be in the recording, our tests for continuity are, is f of c defined? And in this case, c was -3. And is f of -3 defined? Yes, f of -3 is 4. So yes, that step checked out. And then our second step was, does the limit as x approaches -3 exist? And you have to break that down to the question, well, does the limit as x approaches 3 from the negative side equal to the limit as x approaches -3 from the positive side? And we saw, looking at the graph without having to do any math, that if I approach from the negative, I approach 4. And if I approach from the positive, I approach 4. So that tells me that the limit as x approaches -3 from the negative side is 4, and the limit as x approaches -3 from the positive side is 4. Therefore, that limit as x approaches -3 is 4 because these two match. So then the last step is to compare your answers to 1 and 2 and say, do those two answers match? Is the limit as x approaches -3 equal to f of -3? And the answer is yes. Both of those were 4. So therefore, that function was continuous at x equals -3. Now you can prove it's continuous at any other point as well, but I chose particular to look at this point because that's the one point where it did something weird, okay? Something that was kind of unexpected. So let's work through the second example and apply the rules. So in the second example, we have this function. Get it where you can see it really well. And our first question is f of, and the point we're interested in here, obviously, I would hope, is -1. So is f of -1 defined? And if so, what is it? So let's scoot it up and make it a little bit bigger so you can see. Is it defined?
No.
Why not?
It's -2 and 2.
That's not why. It is not
It
2,
would be defined because it's a full circle at -2.
because that's an open circle. But it is defined here because that's a closed circle. It's a dot. So yes, it's defined. And its definition is what happens at the closed dot. What's the value of f of -1 according to the closed dot? It's -2. So check mark on the first step, okay? Second step. Does the limit as x approaches -1 exist? How do you know the answer to that is no? Okay. If I approach from the left, oh, so I guess that's a g of x.
Did you zoom out just a little bit?
Yeah, because we can pretty well see the function now. Let me scoot it up too, not just zoom it out, but scoot it up. So if I approach a negative 1 from the left, what's the value of g of x approaching? Looks to me like it's approaching negative 2. But what happens if I take the limit as x approaches negative 1 from the positive side?
It doesn't exist.
Nah, remember,
Circle.
g of negative 1 doesn't exist, but what happens if I try to get close to negative 1 from that side? What number am I approaching?
2.
It's getting closer and closer to 2, okay? But what does that mean then about whether or not this limit exists? Does negative 2 equal positive 2? No. It doesn't exist because the limit as x approaches from the left does not equal the limit as x approaches from the right. Okay, those two have to match. They have to come together. And they don't. Now, do I even need to go on to the next step? No, I do not, because I already failed right there. So you go through the steps in order. If step 1's a check, go to step 2. If step 2's a check, go to step 3. But if you fail at step 2, stop. You've already proved that it's not continuous. Okay, you don't have to check all 3 steps every time. First one it fails says the answer is no. And I'm trying to watch time here. So let me skip ahead, and I'm going to leave the rest of these for y'all to finish. But I want to make sure you hit every single potential example. So I'm going to start first, look at this one. And the point of interest here, I'm going to do half of this one. I'm not going to do the whole one. The first thing I'm going to do here is I'm going to talk about x sub 4. This is the one we're interested in, is x sub 4. So pay attention to what's going on there at x sub 4. Let's go through the steps.
So in this particular example, we were working this out, we do of x of 4 and x of 1, the 3 different steps.
Yes, and I'm going to let you do x sub 1. But if you notice, we're going to kind of be doing the same thing.
Even if we get that it's not continuous to one, we still do the other.
Exactly. What's the first step? What's your first continuity test? Is f of 4, x of 4 defined? Can you find f of x sub 4? No. Is it continuous? No. Do I need to go any further if this step failed? No, I know right there. That first step said no. As soon as I get the first no, it's not continuous at x sub 4. And in fact, if you were to go on and look to see if there's a limit as x approaches x sub 4, does the limit exist? Yeah. The limit as it approaches x sub 4 is whatever that y value is from both sides. So the limit exists. It doesn't matter that the limit exists because f of x sub 4 does not exist. It's undefined. So no, it's not continuous there. So now that we've established that, we are interested in what is going on here again at x equals 4. There's our point of interest. First question is, what's the first question going to be? Okay. Is it? Does it exist? No. It's undefined. It doesn't exist. Undefined and does not exist mean the same thing. Okay? So given that, do we need to do anything else? No, we've already proven what we wanted to know. There's no step 2, step 3. Okay? You only do the second step if step 1 is a check. You only do the third step if step 1 and 2 are both checks. Do your steps in order. Now, in the 8 or so minutes that we have left, because I'm going to leave you with the rest of those to complete for homework. You've got until later on tonight to do it. If you turn it in at 12 instead of 11:55, and it gives you a little red clock, no problem, don't sweat it, I'm not taking off.
So,
You turn it in on Shelby where you just downloaded it.
turn in the stuff where we did that says continuous or discontinuous, all that stuff?
Yes, turn in the whole thing.
Do we have to turn in what we just went over?
All this?
Yeah, but you want to complete this.
So it's like 6 sheets, 7 sheets, yeah.
Yeah, it's 7 sheets total, and the last page, I broke it down for you for each individual one, because on the last one, it's that same graph you saw on the last page. But this time, the reasons here for the answers are all going to be different. So at x sub 1, the function is discontinuous or continuous. Because, where did it fail if it was discontinuous? Or state that f of whatever is equal to this, and that's why it's continuous. So tell me why. You should be able to do most of 11.2 with no problem. If you have a question about something, either ask my instructor if you're in my math lab, or if you're in Shelby, type me a comment, it comes to my email, and I'll check on it for you. I may not get back to you within 10 minutes when you ask me a question, but I will get back to you within the next few hours. If nothing else to tell you, I can't do it right this minute, but I will look at it and get back to you so that you'll know I got it. Now the question somebody asked, and I'll publish something for this, so let me have one more second, folks.
I don't know if I'll be able to finish this tonight. I gotta go straight to work after this.
Just write me a note and show me and tell me I had to work, but I'll turn it in tomorrow, and that'll be fine.
On the Pearson thing,
Uh-huh.
I know you said that we could do the
Oh, can I go ahead and
homework instead of our quiz.
save, I have the PDF saved already from.
You can go ahead and upload what you've got and then download it and work on it some more. Okay, you can open it back up and work on it some more. I went to the wrong one, sorry.
Now that you said that we could do the skills review homework instead of skills.
Yeah, you just need to tell me that you did.
Oh, I have to tell you this.
You have to tell me you did so I know you'll substitute the grade.
So I have to tell you and then you'll let me know.
Yeah. Until I actually can post the video that shows you how to do the limits at infinity, there's two really good examples right here in my math lab. Okay? And in case y'all hadn't realized this, my 1630s realized it right away, but y'all may not have yet. You have to click on the videos, even if you don't watch them. You have to click on them, at least, before it'll let you do the problems. But I'm giving you a point for clicking on them, so don't get mad. Okay? It's a free point. Click on it. The reason I make you do that is if you then later tell me I'm stuck on problem so-and-so, I'm going to pop over to my math lab and look and see if you clicked on the video and how long you watched it. And if you clicked on it and you watched it for 2 seconds, I'm going to go back to your message and say, go back and watch the video first, and then if you're still having problems, let me know and I'll help you. But those videos are there to help you when I'm not immediately available, and I chose good ones. Okay? You don't need to be the homework there, the
I'll see you in LinkedIn.
We're done. We're done.
I say you
Gorgeous.
Just finished the video with school checks, please. I was gonna start on the actual skills, please.
Yeah, that's fine. That's fine, because I'm going to set all of everything for chapter 11 due the night before the test. That doesn't mean you need, and I know you don't. And you know, that doesn't mean you need to wait that long, but I just don't want anybody to be late on any of it just because they didn't get to it on time. So as long as you're ready for the test, you're good to go.
All right, thank you.
All right.
Have a good day.